Hello, I'm Krishna Narasimhan and welcome to my talk Copy and Paste Redeemed. This is a joint work with my professor Christoph Reichenbach from Frankfurt University. So, given the title, it must be pretty obvious that we are going to talk about some sort of software reuse. So let me begin with a story about how software is reused in the industry. Let's begin with a fictitious story where there is a new software company and they have one developer and they want him, let's call him developer A, and they want him to write a function that can express eating bread with jam. He looks at some API specifications, he figures out that he has to call a function called eat, and he has to update a field called consumed. And voila, he has his job done. A few months have passed, developer A has left the company, there's a new developer, and the software team decide that they want to extend their functionality. They want to be able to express eating bread with butter. So what they do is they tell the developer B that we had a developer A who did something like who implemented a function called function bread jam, and what you're looking for may be something similar, so refer to it. And he refers to it and he sees that this is almost what he wants. What he does is he copies the previous function, pastes it, gives it a new name, and he changes the assignment of the field consumed with the value that he wants to. That's the only change that he makes. And a few years pass, the team has been revamped, there's a whole new team, and they look at the software and they say, come on, it's too small a feature set. We want to be able to include drinking tea. And what happens is that developer C looks at the specifications and he looks at the previous two functions. He says, okay, I have a sketch of what I want, but I need to call a different function. I need to update the consume differently, so I'll rather create a new function. He creates a new function and he makes the changes to the calls from eat to drink and the update of consumed. What you've just seen is one way that software developers extend functionality or implement or reuse features. This is called copy and paste method of extending functionality. Now let's look at the same story, but let's assume that the developers think a little bit differently. The first developer, of course, his requirement is the same. He cannot do it any differently. He implements the function. Then the second developer, he looks at the function. If you remember, he had to change the call of consumed. He had to change the update to consumed. Now, right now, let's assume that the developer thinks to himself, okay, this is almost what I want, so why should I write a new function? Let me just remove this function. Let me write a more generic function eat bread, and pass consumed food as a parameter. And if the consumed food is bread jam, I'll use a switch statement to switch between either bread jam version of it or bread butter version of it. Of course, you should understand that such a change means that there's a new function. There is all the calls to the existing function would break the code. He would have to handle the dependencies accordingly, and he does so. And so the third developer, if you remember, had to implement something called drinking tea. It seems like he would have to write a new function, but he says, come on, I can still add one more parameter. I can make the function even more generic. He writes a function for both eating and drinking. He just passes one more parameter called main item, which branches between bread or tea, and he adds one more case to the switch statement. And voila, we have just one function that can express all the functionalities that we just talked about. Such a way of extending functionalities, we shall call it abstraction. Now, we've seen two methods of extending functionalities. We've seen two methods of reusing code. Now, we wanted to see how they fare with each other. So we devised a user study. We collected 5 users, and we picked 5 near-clone function pairs from open source repositories. These were very popular repositories like Google's Protobuf and Facebook's HHVM and stuff like that. And they were top trending in GitHub at that time. And we removed one function from each pair. Now, what this means is there is a missing functionality in the code base. And we split the users into 2 groups. We said there were 5 users, and we asked one group to extend the missing functionality, implement the missing functionality using copy paste, and we asked another group to implement the missing functionality using abstraction. And we measured the time they took for their tasks, and this is how they fared. So the summary is that the tasks that were completed using copy paste took on average 5.86 minutes per task, and the same for abstraction was about 16.58 minutes per task. Now, if you notice, the completed tasks are different for abstraction and copy paste. This is because for abstraction, some of the tasks were not even complete. So the takeaway from this slide is rather unanimous. It is that users find copy paste quicker. We conducted another user study that followed immediately after the first user study. So what we did was we showed each of the users both the versions of the extended functionality. So for each of the tasks, we showed the users the copy pasted version and the abstracted versions, and we asked them which technique they would have liked to see. We asked them to assume that they were not the ones who were extending the task, but someone else would do it, or they can choose one or the other to be in the code base. And they said, and the results were surprising. For all but one of the tasks, majority of the users said that they would have preferred the abstracted version of the code in their repository. So the takeaway from this slide is that users prefer abstraction. So let's summarize our takeaways from the two studies. The primary takeaway is that copy paste is quicker, it is easier, and our findings show that it has less potentials for error in the short run. This is because when you're copying and pasting to extend functionality, you don't have to worry about what the existing functionality was, where it was called. You don't have to do any of that. You just have to worry about your extension, which means that there is less potential for errors. So we propose that users must copy paste when extending functionalities. This gets the job done quickly, efficiently, bug-free. So why should we have this talk in the first place? Because what about the user preference? What about the maintenance benefits? What about the long-term bug fixing benefits of an abstracted code? Bug fixing benefits? Well, imagine a copy-pasted version where there was a bug in one of the clones. It would have propagated into all of the clones, which means later if the bug needs to be fixed, it has to be fixed in all of the clones. In an abstracted version, there is only one source where the bug must be fixed. So our solution is the best of both worlds. We believe that developers must go ahead and copy-paste when extending functionality as long as they can invoke a merging tool that abstracts the functionalities and handles the dependencies. So now for the rest of the talk, we will discuss an algorithm for such an envisioned merging tool that can abstract functionality, that can handle dependencies. I will describe the algorithm for the copy-pasted example that we previously saw. But before I can describe the algorithm, because the algorithm works on ASTs, I would need to extract ASTs out of each of the 3 functions. And to extract ASTs, I would have to give simpler names. The AST for the initial function, the AST for the second requirement, and the AST for the third requirement. It must be noted that here the function names have been changed from A1, A2, A3 into just A. This is because our merging tool only abstracts the function bodies and not the function name itself, because a new name has to be generated for the merged function anyway. So our envisioned algorithm must be able to do something like this. It must be able to start with n different ASTs, and it must be able to produce an abstracted merged version of the ASTs. If you notice here, there is an open node called MP, which is the merge point, and this node has been kept open because this is not a decision that can be taken at the AST level. This is a decision that can be taken only at the source code level. It involves choice. So basically, to be able to choose between one section of code or the other, one can use a switch, one can use an if, one can use an extra parameter. There are so many other ways which we will discuss, but the point is that MP right now is a choice node. It basically allows the code to choose between either the one or the other version, and the choice can involve multiple branches. Anyway, so right now we need an algorithm that can start with the top three ASTs and can end in the bottom AST. How do we do that? So the algorithm works like this. The algorithm first identifies the common nodes. In our case, it would be A and D. The next step of the algorithm would be to categorize the remaining nodes based on the ASTs that they belong to. For this, we use the notion of a unique set. A unique set is basically the set of nodes that are unique to each subset of ASTs. For example, consider the unique set of 1 and 2. It would be B and C. What this means is that the nodes B and C are part of only the ASTs 1 and 2 and nothing else. The unique set of AST1 would be E and F. The unique set of AST2 would be G and H, and so on. If you notice, there are two subsets which are missing here, which is the unique set of 1 and 3 and the unique set of 2 and 3. The reasons for this is obvious because they are empty. There are no set of nodes that are unique to only the subset of ASTs 1 and 3 and 2 and 3. So now that we have got the common nodes, now that we have categorized the remaining nodes based on the ASTs that we belong to, the next step would be identifying the nodes where a merge must happen. So for example, if you remember the previous end result, a merge must happen between the nodes B and I, and a merge must happen between the nodes E, G, and K. So how do we identify these nodes specifically? For this, we bring the notion of a root set. A root set is basically the set of nodes in that set which don't have a parent in the set. For example, let's consider the unique set of B and C, or unique set of 1 and 2, which is B and C. The node C has a parent in the set, which is B. The node B has no parent in the set. So the node B would be the root set of the unique set of 1 and 2. Similarly, the root set of each of these unique sets is identified. In our case, they would look something like this. So once you identify the root sets, something is very obvious. The nodes that have become bigger now, which is the root set, are the nodes where a merge must happen. So the nodes B and I would be part of one merge point. The node E, G, and K would be part of another merge point. And how do we separate them? We separate them based on positions. If you notice, the nodes B and I are of the same position. The nodes E, G, and K are of the same position. So the last step, or almost the last step, is that every position in the root set is a merge point. And so we have something like this. So what we've done right now is we've taken three ASTs, we've made a new merged ASTs with the merge points marked. Now, how the merge points are resolved is not something that can be resolved at the abstract syntax tree level. It has to be resolved at the source code level because based on the type of node, the merging mechanism differs, for which we introduce the concept of resolution patterns. A resolution pattern is simply a co-transformation pattern that allows merging of certain kinds of nodes. So let's consider some kinds of nodes. Let's say the nodes are to be merged are all of statement type. For example, look at the function 1 here. There is statement 1, function 2 has statement 2, function 3 has statement 3. The difference, assume that the remaining of the code is the same. The way this could be merged is pass the function name as parameter or the function identifier and resolve them using an if conditional branch. Similarly, the same statement level difference can be resolved using a switch. So statement level differences can be resolved using either an if or a switch. Differences in constants and field names. For example, let's assume the three functions, the only difference was a string constant, const1, const2, const3. The constant can be passed as an extra parameter and that's it. The difference is resolved. Same way, the differences in constants here can also be resolved using a global field. I'm sorry, there has to be a change here. It should be global field here. So a global constant can be set just before a call to the function, which would resolve it. And differences in type can be resolved using a template argument. Here, the only difference is type 1 or type 2 or type 3 of the var, and it can be resolved by introducing a new template. Let us see some real real industry code examples of how our merging tool resolved certain kinds of nodes. So this is an example of statement level difference from Facebook's RockSDB database or RockSDB repository. The only difference between the two functions is the statement where the assignment statement where the value of S is set, which S is a status here, and our tool resolved it using a switch statement here. This is an example of a code from Oracle's NodeDB repository. There are three functions here. The only difference between the three functions are the constants client ID, module, and action. Our tool resolved it using an extra parameter called error message. There was a type, and our tool performed a type analysis to figure out that this is a string. This is in fact a string, and yes. This is an example of a clone pair from Rethink DB repository. The difference here is between an int and a double, and it was resolved using a template parameter. The difference is a type here. So we've seen an algorithm, we've seen a potential problem, an algorithm to address the problem. We wanted to see if this really helps in the real world. So for our experiments, we set up our experiments like this. We detected clones from popular open source GitHub repositories. We randomly picked clone groups to merge using our tool, and we submitted these merged versions as pull requests. So pull request is basically this. We ask the maintainer if they would like to replace their existing code with the changed code that we submit. In our case, the changed is the abstracted version of clone groups. In the initial version, we just wanted to see if we can if our tool can actually generate abstractions that don't break code. That is the first, if our tool can actually abstract industry level clones. And so which means we used the clone detector, and we didn't basically care about what kind of clones the clone detector presented. We worked on functions of all sizes, even functions for one line. And we didn't care about how much of the code was different. And of course, we were able to merge about 8 clone groups, but only one was accepted. And based on the feedback, we realized that people, although they liked the clones, although they liked the idea of abstraction, they were uncomfortable abstracting code which did not save them any lines of code. I mean, we ended up merging 3 functions of 1 line each into 1 function of 10 lines, which was not something that people wanted. So then we wanted to see if we can abstract clones that are actually acceptable, for which we set tighter restrictions on the clone detector. We said that we want to work. We basically figured out clones of very large functions and when the differences were very low. And out of 10 submitted clone group abstractions, 9 were accepted. And yes, so the results were really good. So to conclude, copy-paste offers a quicker, more productive development. Abstraction is preferred. It's maintenance friendly. Bug fixing is easier in the future. We propose to offer the best of both worlds. We say that developers must go ahead and copy-paste because it saves a lot of time. It introduces lesser bugs on the immediate task, and we say that we developed a folding tool which merges the code so the developers can choose between the abstracted version or the copy-pasted version. We found that abstractions made by our tool were of sufficient standard to be accepted by industry-level code. Thank you, and I'm looking forward to questions.